So hello everyone, welcome back to another video. In this video, we will learn about data types in Python. So we have number of data types in Python. First, we have number, spatial, sequences, sets, mapping, etc. So let's talk about number. So in number, we have integers, complex numbers, floating point numbers. Also, we have another type which is Boolean. So Boolean, we have two data types, true and false. So this is all about number data types. Now the another one is spatial. So in spatial, we have just only one data type, which is none. So next is sequences. So in sequences, we have list, tuples, strings. So this is the symbols for these data types. So next we have sets. So sets we usually don't much. There is no lots of much uses of this data type. I have not used a lot. So next is mapping. So in mapping we have data type which is dictionary. So this is the symbol for that. So next. So if you have not accessed this playlist, I want you all to access this playlist and start watching from the scratch to the advanced level. Data types can be classified into two types, mutable data types, immutable data types. So let's talk about mutable data types. So the changes can be applied after creation, means we can replace or change it after creation. So here is an example. So list, dictionary, set are the example of mutable data types. So here I have declared a list L variable in which I have declared a list. So this is how a list can be declared. We will learn more about it. We will make lots of program on list. So here I have written L and then index, that is 1, equals to 15. So after writing this line, our list will look like this, 2, 15. So first, in our list, we have 2, 4. But after applying changes in our list, there is 2, 15, means list can be changed. But let's talk about immutable data types. So after creating, no changes can be made. Tuple, int, float, string are the example of immutable data types. So here is a t variable in which I have declared a tuple 2, 4. So the index of 2 is 0 and the index of 4 is 1. When I write here t index of 1 equals to 50, this will give an error as tuple is not a mutable data type, means we cannot change it after creation. Next we have math module. So let's talk about it. Let me change the pen color. So here is the math module. So calling math module. So this is how we can call math module. So when we write import math module can be called. So inside math modules, we have some functions like AVS and FAPS, apps and FAPS. So what these functions do? These functions return absolute value, or can say mod, or can say always positive. So here is an example: print math.fabs -2. So output will be 2, as the we can say these are mod. So inside mod, positive are always positive, even negatives are positive. So this will give an output positive 2. So next we have math.pow. So it is used to find power of a number. So this is an example: math.pow 2, 3. So this will give an output 8. So how this will work is, so let me write here. So this 2, 3 will look like this: 2 to the power 3, which will be equals to 8. So this is how Python will run it. So next is math.pow 0.2 to the power 2. So this will give an output 0.04. So same as the previous one. So next we have math.ceil. So what this function do? It always round offs positive functional number. Next we have math.floor. This always round off negative fractional numbers. So here we have some examples of math.ceil and math.floor. Also, point to be noted, these are very important functions of math module. We have lots of questions in exams about these modules, math module function, which are ceil and floor. So what math.ceil does, when we write math.ceil, in bracket we have to give argument, or can say number. So this will round off. So if this number is negative, or positive, this will round off the positive fractional number. Means the number after the point will get raised, or can say this will give output only for the -2, or can say just for the integer, not give floating point output. So next we have math.ceil, or can say about math.ceil, if there is negative number, it will step back, but if there is positive number, it will go ahead and will give output 3, even if the number is just a very less more than the number. So this will give output 3. So let me summarize. So math.ceil, if there is a negative number, this will give output -2. Means if there is -2.8, this will give an output -2. But if we have positive number, this will round off 2.001 to 3. Means it will, if there is a negative number, this will decrease the number. But if there is a positive number, this will increase the number. So next we have math.floor. So math.floor is just opposite to the math.ceil. So if there is a negative number, this will increase the number. But if there is a positive number, this will decrease the number. So these are just opposites of one another. So next we have math.gcd. So this function is used to find the factors of two numbers. So here we have written math.gcd 12,18. So the factor of 12 is 6 and the factor of 18 is also 6. So this will give the factors of these numbers. So next is math.factorial. So as like we have done programming for the factorial of a number, but also we have a inbuilt functions for factorial. So we have math.factorial, and here is we have argument, so this will give an output 120. And next we have math.fmode, so it returns result into float data types. It results remainder of factorial number. So math.fmode 7.4, 3.3 will give an output like this. So next. So if you have not accessed this playlist, I want you all to access this playlist and start watching from the scratch to the advanced level. So next we have more functions of math, like we have math.sin, math.cos, math.tan. So these functions have default return type float, angle, radian. So these function will give output in angles, radian, and in float. So also we have math.degrees, math.radians. So here is a question: convert following math statement into equivalent Python statement. So here we have under root a factorial b factorial upon a b. So how can we write it into Python? So here we have, so we have to write math.sqrt. So sqrt is used for under root. So after that we have to start a bracket. Then we will write math.factorial a, as here we have a factorial. So a factorial is multiplied by b factorial. So then we will write here multiply sign, and then we will write math.factorial b. So here we have, and then this is the division sign. So for this, and next we will write here a into b. So as in simple mathematics we write av, which can be termed as a into v. But when we are writing it in Python, we have to make this star symbol to tell Python that the two numbers get multiplying. So this is all about data types in Python. Hope you have liked this video. If you found this video helpful, you can like, share, and subscribe. Also, the PDF of these notes are in the description box. You can download these notes absolutely for free. Also, if you have not accessed the playlist, I want you all to access the playlist and start watching from the scratch to the advanced level. So thanks for watching.